get started, I would like to introduce KYZEN's own Will Sweet.
Thank you, Sherry. And good morning, good evening, and good night, depending on where you are in the world, and thank you for joining. We're going to go over a brief talk about hydrocarbon vacuum degreasing, best fit applications for those in particular. Throughout this short presentation, we're going to start off with a brief introduction to vacuum degreasing in general. And then we're going to move on to hydrocarbon-specific applications, and then ending with maintenance, which has to do with both hydrocarbon and modified alcohol. But again, we're going to focus more on the hydrocarbon side of things. So the vacuum degreasing is really, it's the direction a lot of cleaning applications are going nowadays. And really that's in an effort to get more green, to be more environmentally friendly, more user-friendly. And that started back with the fun solvents, as some people refer to them as back in the day, with open-top degreasers, PERC, TCE, NPB. Everyone's moving away from those. Some of those are in some areas of the world are already outlawed. And in fact, if you want to go get a deeper dive into, I guess, the industry moving away from NPB in general, Joe McChesney on this past September 17th, I believe it was, he did one of these texts that goes deep and more in specifically into how and why NPB is going away and how it can be replaced. So I would encourage you to take a look if you're interested. And like I mentioned, yeah, moving away from these open top, the organic solvents due to VOC emissions that are harmful for not only users but for the environment, moving more towards organic solvent, and these closed systems like these vacuum degreasers, closed and very, very low emissions from these machines. Moving towards safe halogenated fluorocarbon solvents like the hydrocarbon. And then, of course, in this move to stay more environmentally friendly, there's always been the strong continued use of aqueous cleaning. There are many benefits to vacuum degreasing in general. In these machines, there's excellent cleaning of both polar and non-polar soils. The non-polar is underlined here because that is what the hydrocarbon materials will remove in particular. So we're going to stick to talking mostly about non-polar soils today. These machines are able to meet a wide range of cleanliness specs while introducing no water to the process. Non-HAP solvents, I mentioned low VOC emissions already. Excellent rust prevention and protection capabilities in these machines. Efficient use of solvent. Reusing the solvent, low consumption rate when the solvent's actually in the machine. It is not zero as far as solvent usage or loss, but they are very efficient, and there's not a lot of solvent used or lost throughout the process. And that contributes to this being a low-cost process. Once the machine is up and running, there's not a lot of other costs that are going into this. This is a diagram, a broad diagram, I should say, of what the inner workings of most vacuum degreasers. If you'll notice in the middle all the way on the left is the wash chamber. That's where you put your parts in a basket, and that basket goes into the wash chamber. And that's where the solvent in the very middle of the diagram, tank 1 and tank 2, that's where it is pumped into. The solvent is pumped into the wash chamber where various different mechanisms are possible. You can set it. Most vacuum degreasers have options as whether you want to add ultrasonics to the mix, or spray and air, spray and immersion. And yeah, there's several different things that you can do when it comes to the mechanics of cleaning the parts. And then after the parts are cleaned, the solvent is then pulled up into the coolant and the condenser up at the top, and then eventually makes its way to the heating distillation. And that's where the solvent is continuously cleaned. So your parts are always seeing clean solvent because this machine is always continuously distilling the solvent and removing the soils from it. Moving on to more hydrocarbon specific applications. Hydrocarbon in general, it's a compound of hydrogen and carbon. So I mean, petroleum and natural gases are essentially what you're looking at. It's great at removing heavy duty oils, waxes, greases, shop dirt. Again, the non-polar comes up. These non-polar soils are what can be removed in the hydrocarbon material, like petrochemical oils as well. We see these types of applications in many different industries, whether it's automotive, electronics, aerospace, medical, anything anything high tech, high reliability. These are really precise and efficient machines for all of these industries. On to part geometries. So if you didn't already notice, the parts on the left are the dirty ones and the parts on the right are the clean ones. If you were to put parts like this into an aqueous washer, you would, if you're familiar with aqueous cleaning, you'd run into a lot of issues. There's a lot of blind holes here. There's parts sitting on top of each other, places where water can't get in and out. With this solvent and these vacuum degreasers, when the vacuum is pulled, it's actually able to get in and out of these low standoffs, these really tight spaces, tight gaps in between these parts. Remove the debris, remove the oil, remove the chips and fines, which you can see on the left as well, and pull it back out. And then, as you see on the right, they can come out nice and shiny. This is an example of the vacuum degreaser in cleaning process. These parts, I believe, are aluminum. They're not like the copper that we saw last slide. But you can see here that there's also rocking capabilities. You can actually tilt it and move it around, as well as not just opposed to the spraying and the ultrasonics. There's a lot of versatility that you can actually have in these wash chambers to clean your parts. And then when it comes to hydrocarbon in particular, this is a compatibility chart. So just the key on the right, the R equals recommended, meaning that with this type of metal, it is recommended to be used with hydrocarbon. The T would be, we would highly recommend you test before you introduce it into regular production. And if it's in, we've tested it and we've realized that it's not good for this metal to come in contact with this solvent. But as you can see, all of these different types of metals, several different types of aluminum, yellow metals, and several types of steel, they're all recommended. So I mean, there usually isn't any compatibility issues when it comes to hydrocarbon solvents. On to the maintenance side of things, best practices. We would highly encourage you to test and develop this process out before you introduce it into regular production. A lot of suppliers, both vacuum degreaser suppliers and chemical suppliers, will allow you to do this at their facility at no cost to you. This is going to ensure that you're going to have proper contaminant removal. It's going to allow you to figure out what your cycle times are going to be, to make sure that you get your parts out clean, first and foremost, but also that it fits into your production schedule. And then compatibility with parts we touched on last slide, but it is very important. You don't want to purchase a brand new machine and then find out that the solvent you're going to be putting into it isn't compatible with some type of metal. So that is a box that I would encourage you to check off before you make this capital investment. And part of this, with testing out this process before you introduce it into regular production, oil testing is part of that as well. And the main reason to do that is to make sure that the oil separates from the solvent in distillation. So one thing you're going to want to look at is the boiling point. And if anything less than 220 degrees Celsius probably isn't a good idea. It's going to be tough to separate that oil from the solvent and continue on with the process. In the same breath, most oils should have a greater than 90% NVR, or non-volatile residue. That's stuff that's not going to evaporate off. So you want most of your oil to be non-evaporative. That just helps with the separation process as well. These low boiling point oils, they can accumulate in the solvent, and some oils actually have solvent in them as well, and they can also accumulate in the solvent and essentially dilute the designed solvent that should be cleaning your parts, and thus hurting cleaning is one of the most common issues you see when that happens. And then, yeah, we touched on last slide, but make sure the contaminant, the oil, is soluble in the hydrocarbon solvent. And on the next slide, we're going to get more into it, but also check to see if there's going to be any acid formation when this oil is removed from the solvent. If acid is found, most cases a neutralizer is going to need to be added to the machine. I would check with your chemical supplier for troubleshooting. I know a lot of people They have a chart similar to the one you see on the right, or a step-by-step instructions, to where you're able to test a sample of your solvent from the machine to see if it is acidic and how much acid is in there percentage-wise. And then it will then spit out a number, how much neutralizer you should put into the machine to get rid of the acid. And then after that, it is still going to need time for the neutralizer to make its way entirely through the machine, through all the solvent. I would advise you to run a full distillation if you're able to, but just don't expect the acid number to drop for at least 24 hours. Once you do find acid, add this neutralizer and then check back the next day. And then corrosion and rust protection. Most of these are wax based. There is a separate tank. So in the diagram, you saw the tank 1 and tank 2 for the solvent. But there's usually a third tank available, and that's where the rust preventative goes. It's added at a diluted rate. We found that between 3 and 7% works for most applications. Concentration is controlled with NVR, that non-volatile residue that I mentioned earlier. And one thing I want to caution you against is if you put one of these wax-based corrosion protectors on your parts, I'd recommend not sending those parts through a traditional vapor degreaser. Those solvents tend to remove those waxes. And actually, that's about all the time we have here. So I'm going to pass it back over to Sherry for any questions that you all might have.
Great, thanks, Will. If you would like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.